Okay, so here's part B. So we talked last weekend, just a couple days ago, about something called Pick's theorem. And what was Pick's theorem talking about?
Well, how to find the area of a shape, given the dots on the outside and the dots on the inside.
Okay. So when you have shapes that have their corners on a lattice, if you count the dots that are on the lattice and you count the dots that are in the lattice, there's a way to find the area. Do you remember what you do to find the area?
Well, you take the dots on the outside and divide them by 2. Divide
Okay.
the number of dots on the outside by 2. Then subtract that by 1. Dots on the outside minus... dots on the outside over 2 minus 1.
Okay.
And then add the number of dots on the inside.
Okay. So let's see, we have previously found that the area of this was 85. So let's see if we can count all the dots. So where do you want to start? Do you want to start the inside or the outside?
Outside.
Okay. So where do you want to start?
Well, let's start this point G.
Okay.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Okay, so we got 14. I'll write down.
There's going to be 16 on here. On this line. HJ.
Why?
Well, actually it'd be overcounting H. But
Okay.
so then there'd be 15.
Okay. So you got to be careful. You don't want to double count this. You're right, there are 16 going up, but you already counted one of them. Okay.
So 14 plus 15.
All right.
And then plus 4. Actually, 3, you're overcounting J if you say 4.
Okay. So how many more do you add?
3.
3.
3. And then start here. 1, 3, 4, 5, 6, 7.
Plus 7.
You only had 3 there.
Oh, sorry. You're right. I wrote 4.
So, and then you don't add any here. So you can see that they don't quite hit on.
Oops.
They don't quite hit on the points. Actually, that one in the middle sort of looks like it hits it.
Okay, so how many more do we have to count?
1.
1. Okay. So we have 14 plus 15 is 29, plus 1 is 30, plus 10 is 40. So it looks like we have 40 dots around the outside. So what do we need to do with 40?
We need to divide that by 2.
Okay. And then what?
And then subtract 1 from it.
Okay, so we have a contribution of 19 from the dots on the outside. Now what about the ones on the inside?
Well, you can just start counting them. Maybe starting up here.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28.
Okay. 28 counting down there.
And then now we have to start at this line.
Okay.
Wait, yeah. We don't count L. 1, 2, 3, 4, 5, 6, 7, 7.
Okay. 7 from that line.
That one's just barely in it.
Okay.
6, 7 again.
7 again. All right.
And there'd be 6 here because that one's not in it.
All right.
And then 5,
Okay.
4, and 3. 3 again. 2. 1. And that's it.
Okay. So we have 28 plus 7 plus 7. What's that?
That would be 42.
So we got 19 and 42. And then we had 6 plus 5 plus 4.
Which is 15.
And we had 3, 3, 2, 1.
So 3. So that'd be 9.
9. So we have 19 plus 42 plus 15 plus 9.
You can say this is 19 plus 9 is 28.
Okay.
And then
28, 42, 15.
70, 15, 85.
There we go. Pick's theorem confirms that the area of that shaded region is 85. It's interesting. Totally different way of looking at it. Now, what I did when I was looking at this with Pick's theorem, because I just counted. So I just said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I just kept going. Same around the side. So I didn't have a bunch of stuff to add up at the end. I just had to make sure I counted them all carefully. But that's neat. It's a neat way of sort of revisiting Pick's theorem. What do you think?
Pretty cool.
All right, good job, hon.